Hey guys, today I'm going to go over your study guide part 2. By the end of this video, you're going to be able to review proportional relationships in tables, graphs, and equations and focus on any areas of improvement you see, not necessarily the things that you're awesome at. So what I want you to do is go ahead, make sure you've done part 1 already. Watch the video for part 1 if you needed help with any of those questions. Then finish part 2 of the study guide. That's questions 8 through 20. And then check it with the answer key. After you've checked it, you want to go back and look at any questions on this video that you had trouble with or you got wrong. All right, so let's pick back up with question 8. It says, I can use a verbal description to represent proportional relationships. These are the real world examples. So question 8 says, write a situation to represent the equation y equals 5x. If you check this on the study guide, it'll say answers may vary. That's because anybody could put something different for this one. As long as you have a rate of 5, if you have something that's changing per every 5, you would have a correct answer. So on your test, you'll see a question that says which situation represents the equation below. And then on the test, it'll say y equals 2.5x. For each of these situations, I use the ride at the fair analogy. A ride at the fair charges $2.50 per person will be the answer on the test. In this one, it could be a ride at the fair charges $5 per person, and then y would be the total amount of money that they make. So if you came to check this question from the study guide answer key, you just got a free question on the test. Number 9 says Danny sells beach towels for $12.50 each. Write an equation to represent that situation. In this situation, X will be the number of beach towels, and Y will be the money that we make. The unit rate is $12.50, so that's our K, and all of our equations are going to be written in the form Y equals KX. In this situation, Y is our total, and that's going to change depending on our X. So Y and X will stay variables. However, the rate is constant. It's always going to be $12.50 for a towel or 12.5. So you can write it 12.50 or 12.5. Either way, this would be the equation to represent this relationship. Number 10 says that Margie saves $7.25 of her allowance each week. Write an equation to represent this situation. In this situation, X is the number of weeks and Y is our total amount of money we make. Our constant of proportionality, or our unit rate, is 725. So that means that our equation will always be Y equals, it'll be 725, since that's our rate, per week, which is our X. Question 11 says, write a situation to represent the equation y equals 0.5x. It will say on the answer key, answers may vary, because you could put anything for this one as long as your rate is 0.5. So I chose the situation, Layla and Lydia sell lemonade for 50 cents per cup. This will be a test question, so if you made it this far in the video, you have a free answer. This matches the equation because 50 or 0.5 cents is the unit rate, or the constant of proportionality. That rate is being multiplied by X, the number of lemonades we sell, and Y is our total amount of money we make. In this section, you should be able to use a graph to represent proportional relationships. So we'll start with this one. This is a graph about gas mileage. We have miles on the x-axis and gallons on the y-axis. Number 12 says, in this situation, what does the ordered pair 0, 0 represent? So it represents the origin, or in context of this problem, you're traveling 0 miles using 0 gallons of gas. You've gone 0 miles and you've used 0 gallons. So the 0, 0 here represents traveling 0 miles using 0 gallons. Question 13 says, how many gallons of gas are required for a 500-mile road trip? So we look on the graph for miles. It's the x-axis. I go over to 500, and I don't see it. So I've got to use an equation. The rule for this graph is always going to be y equals the rate times x, where x is our number of miles and y is our gallons we use. What's missing in this equation is the rate, or the unit rate. I need to know how many gallons per 1 mile I go. And I can do that by using the graph. So the graph shows all these points. All these points I'll label with x, comma, y. And the rule is that I can find the unit rate, or the rate for the graph, by taking any y divided by the x on any point on the graph. That's because this is a proportional relationship. So I can do 2 divided by 50, and I get 0.04. I do the same thing for 6 divided by 150 and 10 divided by 250. So I get 0.04 for every one of those. This is the same thing as 1/25th, so I can write 1 over 25x, or y equals, like we said, 0.04x. Since it's asking how many gallons of gas are required for a 500-mile trip, I'm going to put 500 in for our x. I want to know what 500 is over here on the x-axis. So that would be 20. So when x is 500, y equals 20. You could also look at the graph and look at the pattern. If at 250, we've gone 10 gallons or used 10 gallons, when we go 500, we need to double our amount of gallons. So it's proportional. That's why that works. Let's look at the next one. It says use the graph to answer the questions below. This is a graph about birthday cupcakes where X is the number of hours and Y is the dozens of cupcakes. So this is 2 dozen, 4 dozen, 6 dozen. So pay attention to that. This isn't actually 2 cupcakes. This is 2 dozen cupcakes. Remember, a dozen just means 12. So question 14 says, which ordered pair above can be used to determine the unit rate? So the unit rate means per every 1 X. So for every 1 hour. So the right answer would be 1 comma 3. You look on the x-axis for hours, you go up to 3. Since it's not on a perfect point, you might not know the unit rate from that. So what I would suggest is to mark off all the points that are touching. So like on this one, it's touching on the intersection of the grid behind it. So this point 2, 6 could help us find the unit rate because then we take the y divided by the x value. That's how we know for sure that this is over 1 up 3. You can also tell that this point is between the 2 and the 4, and it's halfway between, so it would be 3. That means 3 dozen cupcakes in 1 hour. So question 15 says, in the situation, what does the ordered pair 5, 15 represent in the graph? Remember, your ordered pair is always X, comma, Y, walk before you fly. That's what I always think. And then it's alphabetical, so X comes before Y in the alphabet. So if 5 is on the X, I look for 5, that's hours. So in 5 hours, we've done 15, which is on the Y-axis, dozen cupcakes. So in a sentence, in 5 hours, 15 dozen cupcakes will be made. Remember, that's 15 dozen, not just 15 cupcakes. This next section is all about computing unit rate. So 16 says a baker's dozen, which is 13. A baker's dozen is different than a regular dozen. A baker's dozen is 13 of cookies is on sale for $2.08. So when I find the unit rate for this, I want to know how much one cookie costs. So when you see unit rate, you should think divide, and then the order matters. So I always want to look at dollars per one. So in this case, one cookie. So you have to divide your dollar amount, $2.08, divided by the 13. That will change your answer because you want to know how much it is per one cookie, which is 16 cents. If you did it backwards and you did 13 divided by 2.08, you found out how many cookies per $1, and that just doesn't make sense for our problem or with the unit rate in real life. So let's look at 17. It says 1 2/3 yards of chain costs $9. We want to know how much 1 yard of chain costs. So we do dollars per yard. So we take our dollar amount, 9, divided by the 1 2/3. I'm going to do this without a calculator. This is how I'd set up my problem, but I never ever divide fractions, and I don't work with mixed numbers. So I'm going to start by making this mixed number an improper fraction. So 3 times 1 is 3, plus 2 is 5. So I have 9 divided by 5/3. I don't divide fractions. I keep, change, flip. I multiply by their reciprocal. So this is going to be 9 times 3/5. And remember, this 9 is over a 1. 9 times 3 is 27. 5 times 1 is 5. I want to know how many dollars per 1 yard. So 27/5 isn't really a dollar amount, right? So I got to go ahead and make this a mixed number with a decimal. So I think, how many times is 5 going to 27? It goes in 5 whole times with 2/5 remaining. 2/5 as a decimal is 0.4, or 2 divided by 5 is 0.4. So 40 cents. So $5.40 per 1 yard. Number 18 says the cost of 2 pounds of cherries is $8.58. What's the unit rate that describes the cost per pound? So it tells you in the question, it's cost per pound. So you want to do dollars divided by the number of pounds. In this case, you're given a dollar amount, $8.58, and you want to divide that by the number of pounds, 2. So $8.58 divided by 2 gives you your unit rate, which is $4.29 per 1 pound. 19 says Jeremy can row 2/3 of a mile in 1/4 of an hour. What is the unit rate that describes the miles per hour? So we know that unit rate means divide, and even though these are fractions, we can write this out. So we'll do 2/3 of a mile per hour. So divide by the number of hours. We don't ever divide fractions. We want to multiply by the reciprocal. So we keep the first number, change the divide to a multiply, and then flip the 1/4 to a 4/1. That gives us a 8/3 because when we multiply fractions, we can just multiply straight across. Now we can simplify this by writing this as a mixed number. 3 goes into 8 2 whole times with 2/3 remaining. So 2 2/3 miles per hour. And then let's look at the very last question. We can compute unit rates and then compare the unit rates. So number 20 says the recipe below shows the amount of each ingredient required to make 4 servings of pasta. Based on this information, determine the amount of each ingredient needed to make 10 servings. So let's look at this problem closely. It says that this 1 3/4 cups of cheese makes 4 servings. So we need to start out by finding the unit rate. In other words, how many cups per 1 serving does this make? We're going to do that by dividing the 1 3/4 between the 4 servings that it makes. I'll show you how to do this without a calculator, but you could also punch this in your calculator. You could type this in as 1 3/4 or 1.75 divided by 4, and you'll find your unit rate. I'm going to go ahead and work it out without a calculator though. So 4 times 1 is 4, plus the 3 on top is 7. So my mixed number turns into the improper fraction 7/4 divided by 4. I never divide fractions. I always multiply by the reciprocal. So I'm going to rewrite this by using the keep, change, flip method. So keep the 7/4, change the divide to a times, and then instead of 4, this will be 1/4. I multiply straight across, so 7/16 is the unit rate for the amount of cups of cheese per 1 serving. Now don't forget, the question's asking how much we need of each ingredient to make 10 servings. So I take what I have here, my unit rate, times 10, because that's how many servings I need. So 10 times 7 is 70 over 16 times 1, which is 16. 70 divided by 16 is 4 wholes and then 3/8 because we had 6 out of 16 left over, which simplifies to 3/8. This will be your final answer for number 1. Okay, so we'll go a little faster on this next one. We have 2/3 cup of milk between 4 servings. So 2/3, instead of dividing by 4, I'm going to times by 1/4. Now I'm going to multiply straight across, so 2/12 or 1/6 per 1 serving. And then I want to take that and multiply that by the 10 that I need. So 10 times 1 is 10 over the 6. 10 divided by 6 gives me 1 4/6, or simplified 1 2/3. That'd be our final answer, 1 2/3 cups of milk for 10 servings. And then the last one I'll do a little fast as well. I'm doing this without a calculator, but you feel free to use that. I just want to make sure you know how to divide fractions, which you should, because you should know how to work with rational numbers. So let me go ahead and start this out by making this mixed number an improper fraction divided by the 4 servings, which is the same thing as multiplying by a fourth. So this is 5/8. So 5/8 cups of pasta serves 1 person. 5/8 needs to serve 10 people. So I'll multiply that by 10. So 5 times 10 is 50 divided by 8. I get 6 1/4 cups of pasta to serve 10 people. This is real life math because you might need to do this whenever you have a recipe or a list of ingredients that serve a certain amount of people, and you need to change it to serve the number of people that you have at your house. All right, guys, that's it. If you made it to the end of this video, please comment what kind of pasta is your favorite. Mine is lasagna, and yes, that counts. Today, we went over the rest of your study guide. So now you should have a really good review of proportional relationships in tables, graphs, and equations. And now you should know what things you're really good at and what things you need some work on. So those focus areas of improvement, I want you to reach out to me with if you have any questions or need more practice on a certain topic. So please let me know if you have any questions. Bye.